So this is the example about slicing and using the function prod for product. Now before we actually jump into the example, it'd be good to actually understand a little bit of the background. This is a mechanical problem with gears, which are shown here. Gears are used in a lot of application. On top of cars, you can also have a marine application. There are two great little videos. How are gears made and how are they used? The video about how gears are made also shows a quick introduction to gears. You can see teeth, they meet together and one makes the other one go forward. The other video shows that with many gears we can actually accelerate or decelerate every piece of a system. But notice how there are a lot of gears. Most of them are of different sizes and most of them are going at different speeds, but they're all connected to each other. Now in the specific problem that we want to solve using slicing and prod, we're going to talk about reduction gears. So gears that are used to reduce an input speed to a slower output speed. So you have someone or a machine or something activating the gear on the bottom right here. It's called a driver gear because it drives the driven gear. Without a driver, the orange gear on the left at the bottom would not move anywhere. So there's drivers driven, they alternate of course. The angular rotation, which is denoted as a W, comes in with a certain speed, radian per second, and depending on the number of teeth of each gear, we can easily calculate the actual rotation speed of the last gear. In order to do that, we do the product of the number of teeth for the drivers, the number of teeth by the driven are at the denominator, and once we have those two products, we can multiply by the rotation for the input gear, and it will give us the velocity for the output gear. If we solve by hand first to get a rough idea of everything, imagine the drivers have 12, 45, and 18 teeth, and imagine the driven have 23, 34, and 20 teeth. So the product of the drivers would be 12 times 45 times 18. The product for the teeth driven would be 23 times 34 times 20. And since the input velocity is 4.8, we could even use MATLAB to help us solve by hand. We should get an output velocity of 2.9831. Now when we're going to develop the software like this, we got to again keep in mind that it can grow. We shouldn't limit ourselves to the 6 gears or 7 gears that we had. We should keep in mind that the number of gears should really be depending on the user's choice. So right now we're going to build an array. We're going to hard code an array with the gears 12, 23, 45, 34, 18, and 20. But we're going to keep an open mind as if I want to add another gear at the end, it should be easy. As far as the script file is concerned, the givens are already set up. Teeths equal 12, 23, 45, 34, 18, and 20, and the angular rotation for the input wheel for the first gear is 4.8 radians per second. Now again, try to develop an algorithm before coding random things and seeing if we're lucky. Basically, we need to extract the driver gears and extract the driven gears. We would like to extract the 12, 45, and the 18. That would be the drivers. Then we would like to extract the 23, 34, and 20. That would be the driven. We're hoping for vectors. Why? Because we can take the product of a vector very easily. We can use prod for both vectors. And then we can divide to get final ratio. Then finally multiply by the input velocity to get W out. So always develop your algorithm first. Try to put what's in your brain using words and just quick little bullets. To extract the drivers is nothing but slicing. Drivers equals teeth, so that's my original array, and I would like to slice the first, third, and fifth number. Keep in mind I could add more, so I want to basically go from 1 to the end, whatever it may be, by increments of 2. Just to tell myself that I am doing this right, I can run 12, 45, and 18. So I am happy, I can continue. The drivens are very similar. It's still the teeth, but I'm now going from number 2 to the end, also by increments of 2. Let's test quickly. So the drivens 23, 34, and 20. Good as well. So I can put a semicolon as soon as I know it works. Take the product, then divide to get the final ratio. We have our two arrays. So the actual formula is the product of the drivers divided by the product of the drivens. That would give me the ratio. And as far as calculating the output velocity, it would be ratio times the input velocity. Now if you remember on paper, we had gotten something close to 2.98. So hopefully we get the same result. After running, 2.9831 definitely confirms what we did by hand. Very little code in here. As you can see, it fits in 12 lines. There is not a single loop. We could do this with loops and tell MATLAB to extract every other value and create a new array, but MATLAB can slice an array very easily. It just is a matter of telling where to start slicing, where to end slicing, and if we want to skip every other element. The prod helped us actually multiply all the gears regardless of the number of gears that we had. So it was a very small example for slicing right here and using prod. If you would like to look at the videos again, here are the credits. Lessons learned. There is not a single loop in this code. It's more work and it's more lines of code. MATLAB is way more powerful than that. Now some improvements that could be made to the solution is of course to interact with the user now. Ask him how many gears, ask him the number of teeth on each gear, loop when invalid because of course we can have negative gears. So now that we know that the math is safe, we pretty much can involve the user and interact with the client.